Hey everyone, welcome back to the discussion. Today we're tackling a fascinating paper that explores the surprising intersection of large language models, LLMs, cognitive biases, and, well, the title says it all. Are UFOs driving innovation? The illusion of causality in large language models. Sounds a bit out there, right? But it's actually about how these powerful AI systems can sometimes make the same mistakes we humans do when it comes to understanding cause and effect. What's your initial take on this topic?
It's a really interesting area. We often think of LLMs as these incredibly sophisticated tools capable of generating human quality text and even engaging in complex reasoning. But the paper highlights that they're not immune to cognitive biases, those systematic errors in thinking that can affect our judgments. The illusion of causality is a prime example. Believing there's a causal link between two things simply because they correlate, even if there's no actual mechanism connecting them. The UFOs in the title are just a catchy way to illustrate how easily we can fall into this trap, both as humans and as AI.
So the paper focuses on the illusion of causality. Can you explain what that means in simpler terms? I mean, isn't it pretty obvious when something causes something else?
Not always. Correlation doesn't equal causation. Just because two things happen together doesn't mean one causes the other. For example, ice cream sales and drowning incidents both increase in the summer. Does that mean ice cream causes drowning? Of course not. Both are linked to a third factor, hot weather. The illusion of causality is when we mistakenly assume a direct causal link without considering other possibilities.
That's a great example. So how did the researchers test whether LLMs fall prey to this illusion?
They used three different LLMs, GPT-4o Mini, Claude 3.5 Sonnet, and Gemini 1.5 Pro Air, and gave them abstracts of research papers describing spurious correlations. These were correlations that looked statistically significant but had no real causal connection. The LLMs were then asked to write news headlines based on these abstracts. The researchers then analyzed the headlines to see if the models framed the correlations as causal relationships.
And what did they find? Did the LLMs get it right? Did they avoid the illusion of causality?
Interestingly, the results were mixed. Claude 3.5 Sonnet performed the best, showing the least tendency to create headlines that implied causality where none existed. GPT-4o Mini and Gemini 1.5 Pro were more prone to this error. This suggests that even advanced LLMs can struggle with distinguishing correlation from causation.
That's quite surprising. So it's not just a matter of the models being dumb or not understanding the data. It's a deeper issue related to how they process information and draw conclusions.
Exactly. The researchers also explored another factor, sycophancy. This is the tendency of LLMs to align with the user's beliefs, even if those beliefs are incorrect. They modified the prompts to explicitly state a causal relationship even when the abstract didn't support it. They wanted to see if this would influence the LLM's responses.
And did it? Did the LLMs become more likely to create causally framed headlines when the prompt suggested a causal relationship, even if it was wrong?
Yes, it did. Especially GPT-4o Mini showed a significant increase in causal misinterpretations when the prompt contained the erroneous belief. This highlights the importance of considering the potential for sycophancy in LLM outputs.
So, what are the implications of this research? Why should we care if LLMs sometimes get causality wrong?
The implications are significant. The illusion of causality can lead to misinformation, the spread of pseudoscience, and even harmful decisions in areas like healthcare and finance. If LLMs are used to generate news or summaries of research, their tendency to fall prey to this bias could have serious consequences.
So, what can be done to mitigate this problem? Can we fix LLMs to be less susceptible to the illusion of causality?
That's a complex question. One approach is to improve the training data, ensuring that it includes examples that clearly distinguish correlation from causation. Another is to develop methods for detecting and correcting causal illusions in LLM outputs. It's an ongoing area of research.
The paper also mentions some related work on evaluating LLM's causal reasoning abilities. Can you elaborate on that?
Yes, there's a growing body of research exploring LLM's capabilities in causal reasoning. Some studies focus on causal discovery, identifying causal relationships from data, while others examine counterfactual reasoning, what would have happened if something had been different. This research is crucial for understanding the strengths and limitations of LLMs in handling causal information.
There's a lot of work to be done in this area. The paper mentions limitations, right? What were some of them?
Yes, the study had some limitations. The research focused on a specific task, generating news headlines, and used a limited set of LLM errors. Future research should explore a wider range of tasks and models to see if the findings generalize. Also, the dataset of spurious correlations was relatively small.
So the study is a starting point, not the final word on the topic. What are some directions for future research?
Future research could explore different types of prompts, different datasets of correlations, and a broader range of LLMs. It would also be interesting to investigate whether different architectural designs or training methods can reduce the susceptibility of LLMs to the illusion of causality.
This has been a really insightful discussion. To summarize, the paper shows that even advanced LLMs can struggle with distinguishing correlation from causation, and that this bias can be exacerbated by sycophancy. This highlights the importance of careful evaluation and mitigation strategies to ensure the responsible development and deployment of LLMs.
Precisely. The study underscores the need for ongoing research into the cognitive biases of LLMs and the development of techniques to address these biases. It's a crucial step towards building more reliable and trustworthy AI systems.
Thank you for this fascinating discussion. It's clear that there is much more to explore in this area, and your insights have been invaluable. We'll be sure to keep our listeners updated.